try to do as many as I can that are kind of alike here as possible. So the instructor's kind of helping here. He's saying use u-substitution to solve. And what the instructor is not telling you, well, what is u? So u is almost always this middle thing right here. It's, in this case, it's u equals x squared. Okay. And if you square u, well, then you have to square the other side. And that becomes x to the fourth. And so you actually are substituting for two things. You're replacing this middle term. It becomes 3u because x squared is u, but this x to the fourth is u squared. So you've got u squared plus 3u plus 2 equals 0. Do you follow how that transformation took place?
Yeah.
Okay, now the idea is, and there's a lot that goes into this that doesn't really matter for you. The idea though is if you solve this and you back substitute, you're good. Like it just works. So this is a quadratic, and there are a number of ways to solve a quadratic. There are factoring, completing the square, quadratic formula, graphing, so on. This one we're going to just factor, kind of the plain style here, u plus 2, u plus 1. So if you were to FOIL this line in your notes, and I'm jumping through this a little bit faster because there's a lot more to do here, you would get back to the previous line. Okay.
Right.
Okay, now you feel really good about this. You set each of these equal to 0, like you've always done. And the mistake here is to think you are done at this step, because you are not done. This is true if you're solving for u, but u is really x squared. So there's this step now where you have to back substitute. So instead of u, you write x squared equals minus 2 and x squared equals minus 1. And this is what you need to be able to solve.
Right.
Okay, so I will help you with that, but is it clear that you're going to make a substitution in almost all these problems, solve it, then back substitute, and then solve it?
Yeah, it does.
Okay, so this is, you got to take a square root of both sides. It's plus or minus the square root of -2. So the square root of -2 is the square root of -1 times the square root of 2. The square root of -1 is I square root 2. So x is plus or minus I square root 2, which I don't see in your answer. Oh, I'm looking at the wrong problem. Forgive me here. Okay, yeah, so that's in your answer space. Now we go to this other one on the right. You take the square root of both sides, so it's plus or minus the square root of -1. X is plus or minus, that's why it's very important. The square root of -1 is I, so it's plus or minus I here. You can probably see that that's B. We're going to do another one just like this, but before I proceed, is there anything you'd like me to clarify? We will be doing the same steps for this next one, number 3.
So we got 1 and 2 by we were trying to get 3, right? The middle term, the B term, or whatever you
Right
want to
here.
call it.
Yeah.
Yeah.
So 2 has factors of 1 and 2.
Okay.
And those are the only ones that work here.
I was just trying to make sure that's what we're trying to do. I feel like they sometimes just pop out numbers out of nowhere.
Yeah. All right, so number
but that's how I felt.
yeah. And so number 3 is very similar. Your u is the middle term, the middle x term, so it's x squared. And then if you want, you can square both sides and actually work it out, but it almost always becomes this first one. Okay, so this becomes u squared minus 5u minus 14 equals 0. Now this problem, I will emphasize that you have to find 2 numbers that multiply to minus 14, but add up to minus 5. It's the a equals 1 factoring type. So it's minus 1 and 14, 1 and minus 14, minus 2 and 7, 2 and minus 7. And this last pair here, which I don't even know if that's a pair, but those last set of numbers work here. So you get u plus 2, u minus 7 equals 0. You set each of those equal to 0. So this is truly a synthesis of like all the things you've been learning, where you get to here and you're like, ah, I'm done. No, you got to back substitute or back sub. You might have seen that in chemistry class. I vaguely remember something there. So this is x squared equals minus 2, x squared equals 7. It doesn't really matter the order. Let's do the one on the right here because it's nicer. The square root of x squared equals plus or minus square root of 7. So x equals plus or minus the square root of 7. And because you're multiple choice here, sometimes that helps. Looks like that gets you down to like,
Usually you can take it down to like 2.
2, which is good. That's the good way of multiple choice. One good way. On the left here again, square root of x squared equals plus or minus the square root of negative 2. X equals plus or minus square root of negative 1 times the square root of 2 plus or minus I square root of 2. So again, that square root of negative 1 is always I.
Right.
So if you didn't fully understand that, I mean, you should start patterning. You should realize, oh, if it's a square equals a negative, my answer is going to have an I in it. That will also help to reduce some of the answers. Yes, exactly. Exactly. All right. Okay, let's do 5 next. We'll absolutely come back and do 2 and 4, but the order here will help for understanding. Any questions on that previous one before I move on?
No. Yeah, that makes sense.
So again, similarly, you gotta factor this after you make your u. Your u is always that middle one. It's not 9x squared. It's just the x squared. So your u squared is x to the 4th. So your new problem is u squared minus 9u plus 8 equals 0.
Yeah. Then we try to find 8, right?
Yeah, 8 is 1 and 8. It's 2 and 4. And you're like, well, 1 and 8 add up to 9. Well, when you have this case, there's 3 cases of this type of factoring, this a equals 1. This is the one where you actually want negatives in both places.
How do you know you're supposed to want negatives?
So like 8 by itself, 1 and 8, 2 and 4 work, but they don't add up to a negative number.
Oh, I
Yeah,
see.
and it's kind of non-obvious, you know, what it is that you're looking for. So this becomes u minus 8, u minus 1 equals 0. All right, so we set each of those equal to 0. U minus 8 equals 0. U minus 1 equals 0. So you get u equals 8, u equals 1, x squared equals 8, x squared equals 1. Okay, so you take a square root of both sides. I'll do the one on the right first. That's slightly better. Square root of x squared equals plus or minus square root of 1. Please don't forget that plus or minus, super important. X equals plus or minus 1 because the square root of 1 is 1. It is friendly. X squared equals 8. You're going to take a square root of both sides, plus or minus. And you'll notice there is no square root of 8 in your answer space because it does reduce. Okay. I don't have a ton of, I guess I'll do it over here. You do a prime factorization. I can't remember if we've done this or not.
Yeah, we kind of did.
Like, so you're looking for like true pairs where they're actually the same. And for each pair, you bring one out. So it becomes plus or minus 2 because you're bringing one out. Square root of what's left over, which is 2. And that should lead you to the right place for that.
Yeah.
All right, let's continue here. 7 and 8 are really similar. Let's do 7 first.
Okay.
Actually, one of the first, I'm sorry, 8 first. One of the first lessons where your instructor actually is giving you a bunch of the same type, where you just over and over again do the same thing. So, your u is x squared, u squared is x to the 4th. This is another way that I present it, kind of a little more horizontally. So that gives you u squared plus 6u plus 5 equals 0. And then you're trying to find two numbers that multiply to 5 but add up to 6, 1 and 5. So you get u plus 5, u plus 1. The order doesn't matter. Could be 1, could be 5, doesn't matter on this one. All right, so u plus 5 equals 0, u plus 1 equals 0, u equals -5, u equals -1. This is where you back substitute. So that's x squared equals -5 and x squared equals -1.
This one. Yep, and then we take the square root.
Yep, plus or minus the square root of -5, plus minus the square root of -1. So the one on the right is plus minus I. Whenever you have a negative, that means you're going to have an I square root of what's left over.
Okay.
Any questions on that? We got one more to do like that, but there's no difference.
No. Yeah.
Like maybe not the speed I'm doing it, but do you feel like you could do this on your own? Like not necessarily this one, but a problem of this type. Like, do you feel good about it?
I feel a lot more confident about it than I did when they were doing it like in the lesson. I'm like, wait a minute, you just did it, but I don't really understand what you just did. So I understand we went through the process. I feel like I could redo it. Yes.
Great. It's yeah, I mean, it just so this one's just bigger numbers. 500's a pretty big one to factor. It's probably easier if I just give you the answers here, maybe. Actually, I'm not even. So 1 in 500, 2 in 250, 4 in 125. Now, what I'm looking for is they've got to be about 95 apart, because actually one of these has to be positive and one of these has to be negative. And then there's 5 and 80. No, sorry, 5 and 100. Boy, and there it is. So there it is, 5 and 100. Do you see how they're 95 apart? 5 and 100.
Oh, yeah. Okay.
Okay, but to get to -500, which is what we really wanted, that means one is positive and one is negative, and so on. Okay. So in this case, you got a choice. Is it u plus 100, u minus 5, or is it u minus 100, u plus 5? And the answer comes down to, well, which of these two adds up to positive 95? Is it 100 minus 5, or is it minus 100 plus 5? Which one gives you positive?
100 minus 5.
Yeah, so this one's no good here. And that's how you decide. So you got u plus 100 equals 0, u minus 5 equals 0. So I get u equals minus 100, u equals 5. And then we change that to x squared equals minus 100, x squared equals 5. X equals plus or minus the square root of minus 100, x equals plus or minus the square root of 5. The one on the right is done. There's nothing else that can be done here, but on the left, it's the square root of -1 times the square root of 100. 100 is friendly. We know that one. This is I. So you might see plus or minus 10i, something like that. As well as these ones on the right here.
So that would be C, right?
Checking. Let me look here. 10i. Yes, that would be correct. All right, I need 2 minutes. We have plenty of time here. Just if you'll permit me, I need to do something. I'll be right back.
Yeah, that's fair.
All right, I'm back here. Let me know when you are ready to start again. Thank you so much.
Yeah, I'm ready.
Okay. So we're going to look at question 2 next.
Yeah.
2 is this other type that you might see. It's a little weird, a little wonky, but it falls into the same category. So what you do is, again, you let your u, and they're telling there's a u, but they don't tell you what it is. Your u is this thing, this x minus 5. So when you square it, you get x minus 5 squared. And again, it tends to completely replace the first thing. Okay, so it's like this x minus 5 squared, which is u squared. This right here is going to be u squared plus 3u plus 9 equals 0.
Okay. So instead of like just the x, we're doing the x problem, I guess.
Yeah, and so the quadratic formula is x equals, but it really now is u equals. It's u equals opposite of b plus or minus the square root b squared minus 4ac all over 2a. And so we really need our a, our b, and our c. So a is 1, b is 3, and c is 9. So we get, and we're just plugging in now. So minus 3 plus or minus the square root 3 squared minus 4 times 1 times 9 all over 2 times 1. This is minus 3 plus or minus 9 minus 4 times 9. So 4 times 9 is 36. 9 minus 36 is minus 27 square rooted all over 2. Is that okay so far? Like, is all of that okay?
Yeah, I'm just catching up.
It's like this part right here we've done before, this quadratic formula, and then the new thing is this, and then there's there's a wrapper on each side. There's a new thing, then it's an old thing, and then it's a new thing. It's totally doable, but it's a lot. It's not easy. You got to know step A, step B, step C. So like here, like when you're looking at like what's left, you have to realize, oh, I can reduce the square root of negative 27 because it's -1 times the square root of 27.
Right.
Okay, so it's -3 plus or minus I, but what is the square root of 27? Well, it's 3, 9, 3, and 3. It's another thing that you can separate, and you get 3 root 3 over 2. And the mistake is to choose answer A at this point, because this is u. We're not solving for u, we're solving for x. So you cannot forget to back substitute. So there are calculus students that have to do something similar to this, and they do forget. And if you remember, oh yeah, I always got to back substitute, I'm solving for x, not u, you stand a chance here of getting it correct. Okay, so we add 5 to both sides. And to add 5, it's not ideal, but here's what I'm gonna do here. I'm gonna change 5. 5 is really 10 divided by 2. So this is -3 plus or minus I3 square root 3 over 2. But then it's really plus 10, and then you keep the bottom. Because this is really 10 over 2. This 5 is 10 over 2, so you keep the bottom there. And then the -3 and the 10, they combine to make 7.
Wow. Really complicated.
Very much, yeah, a lot there, a lot of kind of misdirection and things like that. So you can definitely do this. It's just not ideal. It's not not as simple. Like any one part of this you can do. You got to be getting close to a test or end of a chapter if you're doing this stuff, I think. Oh, well, actually, you only had one of these. So let's, because the next one, I'm going to go to 6 before I come back to 4. This one is not actually asking you to solve it. It's just doing the whole which of the following.
I kind of like those better, but I also find them frustrating because sometimes I don't see that and I put them all the way through. I'm like, wait a minute, what?
Yeah, you gotta read them all. Usually start from the bottom up. So u is x squared minus 1. It's always this middle one, almost always. Okay, and then you square both sides. You do not have to expand. I didn't say that yet, but you do not expand. You don't FOIL this. You just leave it because it's almost always this. So that becomes u squared minus 11u plus 24 equals 0. This is probably like the first question that we should have done now that I see this, because it kind of like steps you into what the U thing is. Do you see that the correct answer there is letter A now?
Yeah, it took me a second because at first I thought it was C. But then I finally saw the problem.
We've got just a tiny bit of time here. What are the two numbers? We need to get to -11. Could you take a moment here and see if you can figure out which two numbers? We're not going to actually do this, but just if you'll just, just practice this. All right, do you have an answer for me on this one?
Yeah, it's -8 and -3.
Perfect. Perfect. All
It
right,
took me a
excellent.
while. I thought it was going to be 4 and 6, and I'm like, wait a minute, that equals 10.
Right. Yeah, you definitely got to be able to do that type on your own there. Okay, so I think we are just down to 4. Is that right? Is that your?
Yes.
Okay. So this one, we got to do one at a time here.
These are the problems I really dislike. You have to do all of them.
Yeah, this one is definitely it's a scramble here. So there's a couple of quadratic forms. The one that I think your instructor is looking for is the more generic one, which is ax squared plus bx plus c. Okay. Or like kind of like what we've been doing today, au squared plus bu plus c. But you can make small modifications here, like let's say this is squared. It's bu squared. That would make this au to the 4th. And let's say you cube it, it becomes au to the 6th.
Okay.
Okay, so I'm kind of hinting at you might want to look for kind of this patterning, you know, a 6 and a 3, for example. And like I'm seeing that in the third one there. And it's kind of hard. It's kind of hard for me not to just tell it to you, but it comes from like you being actually x, or you could square it, or you could cube it. But notice that this is always double. See how these are double?
Yeah, I do.
That's what you're looking for. That's your kind of your shortcut, your hint.
We had a problem that it was one of those ones where they're like, what's wrong with this? Is this right or is this wrong? Actually, kind of question.
Yes.
It had a 9 and like a 3. I was like, that doesn't seem right, but I wasn't really sure why it wasn't right. But that makes more sense. Like they're supposed to add up to, like, I mean, 3 plus 3 equals 6. You know, 3 plus 3 does not equal 9.
2 plus 4, or 2 plus 2 is 4. 3 plus 3 is 6. 1 plus 1 is 2. Just like you said, yeah. All right. Now, is there any way for you to get us another, like if we just waited a minute or two, could you grab another homework assignment for us to work on?
Yeah, I can grab something.
Because we got enough time here to get a bunch more questions done.
Yeah. There was actually one a while ago where my teacher worked it out on the board, and I have no idea how she got to what she got. So maybe I'll just bring up that picture of that as soon as I find it.
Okay. If you're able to send it by either email or drop it in the chat, that's best for me.
So I sent something in. You should be able to see it.
Yeah, I see you sent something in the chat here. Let me just get this and get it open also. Click to open.
I
Right.
feel like
Oh,
that's the one I was thinking of, but I feel like I saw another one. But yeah, that would be.
it's a polynomial division.
Yeah, I somewhat got it, but like when my teacher was putting on the board, I was like, wait a minute, what?
Yeah, it's a little bit odd. So did you get an example of like, let's say, make it not super crazy, but do you remember how to do like 7 into 1508?
Yeah, you divide what the first thing that you can divide into. So like you can't
Exactly.
divide
So,
it into one, so you go into 15.
right, you don't necessarily have to get something here or here, like you fill that in. Okay, great. This example you provide is not the best one to start with. Can I start with an easier one, or do you truly want to do this
Yeah,
one?
that's fine.
Okay, so this is your more traditional problem. Is you would say, what is x minus 1 divided by 4x cubed minus 3x squared plus 8x plus 7? Is that okay?
Yeah.
Something like that. Okay. So you have to know, and this goes back to what goes in the house, what goes outside of the house. X minus 1 goes out of the house. 4x cubed minus 3x squared plus 8x plus 7. They all go in the house.
Okay.
So this is the setup. This is the start. And that's given in the problem you were doing. But sometimes you do have to set it up here. All right. So this is very verbal. So you have to, if I'm unclear with anything I say, just ask me to repeat.
Okay.
You need to get 4x cubed right here. What do you multiply x by to get 4x cubed?
4 and cube. Like that's, you're adding a 4 and you're adding a cube sign to the x, right?
Okay, so let me give you the answer. The answer here is 4x squared.
Oh, because there's an invisible one. Yeah. Okay.
So this is hard for me because I don't really have the right words to like
magically make it make sense.
Yeah, but like I can try here. What you're doing is you're essentially dividing this thing 4x cubed by x. Okay. But you're now taking this 4x squared. This is kind of off to the side here. You're taking this 4x squared and you're multiplying it by x minus 1. So that gives you the 4x cubed minus 4x squared. Do you see that?
Uh-huh.
And that's what goes here.
Okay.
So if we go back to this, like 2 times 7 is 14. Where do you write the 14? You write it there. Now, do you see how you subtract here?
Yeah.
You have to subtract this. Now there's two approaches. The first is to subtract and put everything in parentheses here. That's approach number 1. The second approach is to change the sign of everything and add. And so what I mean by that is you would write, well, I'm going to add, so I got to change the sign. I got to change the sign.
Okay.
Which do you prefer?
Just I know my school wants me to change the sign, so I guess we'll just go with that.
They are the same. Like you're not doing it wrong by doing it, option 1 versus option 2. They're very much the same.
Okay. So
you're adding here vertically. So this is 0. It's the leading one is always supposed to be 0 if you've done it correctly. These are like built-in checks.
You can tell very first off that if you got it correctly or not.
Exactly. But that's the point. Like I think as a math student, and I want to know this when I'm doing other things in life, like, did I do it correctly? Because if I can do it correctly one time, I can do it correctly a second time, and so on. And that's what I'm trying to get you to see here. So this 1x squared, and then you can bring down the other terms, just like you do up here, right? See how we bring them down?
Yes.
It's the same thing. So if you're ever stuck, you go back to like what you did before. All right, now it's the same question we asked over here. What do you multiply x by to get 1x squared?
1x?
Yes, plus 1x. Now I have to line it up in the correct column. Like I don't put the x squared first. I don't put the x. I have to line things up. So again, kind of off to the side, here's what you're doing. 1x times x minus 1 is x squared minus x squared minus x right there. Okay, and again, you have a choice here. Do you change the sign or not? It's up to you.
Just not, I guess, to make it a little bit easier.
All right, for just a moment here. So when we do this, it's negative and plus, and so you're going to get 9x plus 7. Okay, and it feels like a long process, but
I guess it's not any longer than a regular division problem, technically, right?
yes. So same question again. What do you multiply x by to get 9x?
9.
So you put a 9 there, and again, off the side, if you want, you don't have to write this, but this is what you're doing. You're 9x minus 9. So you get 9x minus 9, change the sign, 16.
Right.
Okay, now this is very important. All solutions have the following presentation, but quotient plus remainder over divisor. And you're like, okay, well, what does that mean, Matthew? Here's your quotient. Here's your remainder. I'm sorry, I already messed this up. Quotient and divisor. Okay, so whatever you get down here, which could be 0, whatever you get up top, that's your Q and that's your divisor. So in the problem I gave you, your quotient is all of this stuff up top here. 4x squared plus 1x plus 9. Plus your remainder, which is 16. And your divisor was x minus 1. However, your instructor will almost certainly give you problems where the other form of the solution is quotient, and these are in parentheses, times divisor plus remainder, even though this is fairly standard in the world of math.
Yeah, but nothing can be too standard, right? Everyone has their own way.
Yeah, I don't know, like when I park my car, I mean, there's like, you pull in, you back in. I mean, those are the rules, right? Like, I don't sideways it. I just, you get your car in the space. It's kind of like that here. It's like, I don't know why there's more than one way to do it. You just get it going. Okay, so let's look at another problem here that you might see. Let's go x minus 3 into 4x squared minus 3x minus 2. Okay. So kind of the same deal here. What do you multiply x by to get 4x squared?
4x.
Now the answer, you're correct. The answer is 4x squared divided by x, whatever that becomes.
Okay. Which is still 4x.
So it is 4x, and that goes here.
Okay.
And then you take this 4x and you multiply it by each of these. Now I was doing it off to the side, but you kind of mental math it. You just say, oh yeah, it's 4x squared minus 12x. I got it. Okay. But then you got to change the sign.
Right.
So now again, this first term should be 0. 9x, bring this down, minus 2. And then you start over. You say, well, what do I multiply x by to get 9x?
9. So you
9.
got plus 9.
Yep. Again, you change the sign. Okay. So this up here is your quotient. This is your remainder, and this is your divisor.
Right.
So you write your answer as quotient plus remainder over divisor, which is 4x plus 9 plus 25 over x minus 3. Okay, now we're going to do your problem, maybe. Yeah, we'll do your problem. It's a good one to do. Yours is slightly more complicated. complicated, but it's doable. It is the same steps. It's just got more kind of like more of each little step rather than being kind of building up to it. You probably see me do this a lot. Like we want to gently increase the difficulty. Unfortunately, this is not a gentle increase of that. So the first thing you ask yourself is, what do you multiply this leftmost thing, 3x squared, by to get 3x cubed? And the answer is going the other way. Like, what does this become? And it's x. This equals x.
All right. Yeah.
So does x go here, 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 or here? Well, it's x to the power of 1. And so you have to line it up with that right there, the x column.
Oh, so that matters now.
It does matter. Yep. You got it. You got to line it up. You got to get it in the right spot. You know how to do this from long division. It's just that you probably hadn't thought about it this way when you did long division.
Yeah, not really.
Yeah.
It's been a while since like all I was going in school was like long division.
Yeah. So again, you multiply this all by x. 3x cubed plus 2x squared minus x. So notice you have 3 terms this time. That's okay. You just carry it. It's the same, same set of steps. You just happen to have more terms here. But now you have to change the sign of everything. So I'm going to do that in another color here, just in case you look back. Minus, plus. Okay, and then you add them together. So this is 0, 12x squared plus 8x, then bring this down minus 4. And then you repeat. You say, okay, what do you multiply 3x squared by to get 12x squared? Or you take the 12x squared and divide it by 3x squared to get your answer, 4. And again, you take that 4 and you got to multiply everything. 3x squared, 2x minus 1. And it's a rinse and repeat. You did the same thing over and over again. 12x squared plus 8x minus 4. Okay. Again, very important that you change the sign. If you don't change the sign, you may see something that doesn't work because that first term won't cancel. But you can see these actually all cancel. So this has a remainder equal to 0. Quotient's up here, divisor's here, and you go. Then write your answer. So again, it's quotient plus remainder over divisor. Your quotient is x plus 4 plus 0 over 3x squared plus 2x minus 1. When your remainder is 0, you actually don't write this term. You actually just leave it like this.
Okay. Because you don't really have to, because you don't have a remainder.
No, yeah. All right. Let's see here. Let me have you try a short one on your own. Let's go x minus 7 into x squared plus minus 8x plus 7. Okay. Go ahead and try this one on your own, please. How are you doing on this one?
Okay, so I got X so far and +1 in my quotient.
This one is -1 because you want
Ah.
minus X here. Minus X plus 7. That's a little wrinkle to what we did. I didn't catch that here. But this ends up being it.
What?
Remember, you really want to get exactly what it, like these have to always match. Maybe highlight those or something, but these have to be exactly the same. These have to be exactly the same. All these other ones we did, it was exactly the same. Before you change the sign, it's exactly the same. All right. Well, I think that does take us pretty much to the end of our lesson for today.
Yeah.
I'm glad we were able to get into some new stuff. You can always queue up multiple assignments if you feel like that is possible for us to do. I'm happy to go through as fast as we can. Get you through, get you caught up, get you ahead again, maybe in school.
Yeah. I will try to make sure I'm able to do that sometimes. As long as I'm able to, I'll put it in the homework.
All right. So, excellent. Well, I will send you the notes and the screen recording here shortly, and I'll see you next time.
Thank you.
Bye now.
Bye.